Hello everyone, this time I will discuss the material about Hooke's law. Before starting this presentation, I will introduce myself first. My name is Laviga with student ID number is 24055311024. I will present this material to follow with the basic biological practikum in Sigma. Okay, I will discuss about elasticity. What is elasticity? Elasticity is the property of a material to return to its original shape or size after the force acting on it is removed. When a force is applied to an object, such as stretching or compressing, this might temporarily change its shape. However, if the applied force does not extend the material limit, the object will return to its original form. A simple example is a spring or a rubber band. When pulled, it extends, but when released, it goes back to its internal length. Okay, basic concept of elasticity, stress and strain. Stress, the force acting on a material per unit area of the surface on which the force is applied. It indicates how much internal pressure a material experiences when subject to an external load. The formula is sigma equals F over A, where sigma is stress and F is applied force and A is the cross-sectional area of the material. Example, when you pull a metal wire, the pulling force acts over its cross-sectional area. The smaller the area or the greater the force, the higher the stress on the wire. And 2 is the strain. Strain is the ratio of the change in the length of material to its original length. It describes how much deformation occurs when a material is stirred off or compressed. The formula is epsilon equal delta L over delta L0. Next, a relationship between stress and strain. As long as the material remains within its elastic limit, stress is directly proportional to strain. This relationship is known as the general form of Hooke's law, expressed as sigma equal A times epsilon, where A is a modulus of elasticity or Young modulus, representing the stiffness of the material. The larger the value of A, the stiffer the material. For example, steel has a much higher Young modulus than rubber, meaning it is much harder to stretch. Okay, now we will talk about Hooke's law. This law was formulated by Robert Hooke, an English scientist, in 1616. Hooke was a pioneering mechanic and elastic. He first expressed his discovery in Latin, potentio sic which means as the extension so the force. His experiment with metal spring led to the understanding that most solid material behave elastic under small force. The definition is Hooke's law that the deformation or starting or compressing of an elastic material is directly proportional to the force applied to it. As long as the material elastic limit is not extended, in simpler terms, when you apply a force to a spring or elastic object, it will change shape, and when the force is removed, it returns to its original shape. The formula is F equals G times delta X, where F is applied force, K is spring constant, and delta X is extends or compressing. Okay, next we will talk about the image in your screen, guys. You can see the image shows a vertical spring before and after a weight is attached to it. On the left, the spring hangs freely without any load. This is the original length of the spring, denoted as L0. On the right, when a weight is attached to the spring, it stretches and becomes longer. This is the new length, denoted as L. The difference between the two lengths is represented by delta x, okay? Which is the extension or change in length caused by the applied force or the weight. According to Hooke's law, this extension or delta x is directly proportional to the applied force. As long as the spring is within its elastic limit. In simple terms, the heavier the load, the more the spring stretches, but only up to a certain limit. If the load becomes too heavy, the spring will lose in its elastic and not return to its original shape. Okay, now we will go into the result of the practicum report that has been carried out and the direct application of Hooke's law. In the slide, you can see some of the documentation that we did during the measurement. I did this with my group mates. Nah, experiment 1 is Hooke's law. 1 is purpose of the experiment. To determine the spring constant, and 2 to understand the elongation characteristic of a rubber band. Basic concept: some material or structure can exhibit elastic property. Elastic refers to the ability of a material to return to its original shape after an external force causing deformation is removed. This deformation can occur in various forms, such as stretching, compressing, bending, or twisting. When the external force is no longer applied, the material tends to return to its original state, unless the force is too large, in which case the material will experience permanent deformation or even fracture. The internal force that resists deformation is called a restoring force, while the external force that causes deformation is called the applied force. In equilibrium, that's two forces are equal in magnitude, but opposite in direction. Next, we will talk about the figure 1.1 and 1.2. In figure 1.1 is the loading and elongation of a spring. These figures show the change in the length of a spring when a load is applied. There are two conditions being compared. 1 is spring without load, and 2 spring with a hanging mass. And in figure 1.2 is this diagram illustration the behavior of a material or such a metal when subject to an increasing external force. It shows the relationship between stress and strain, describing how the material deforms from the elastic region to fracture. Research procedure, equipment, and experimental data result. You can see in experiment setup and procedure, A is equipment, first is stand and flap, second is spring, third is mass hanger and weights, 4 is scale or ruler, and 5 is pointer. Determining the spring constant. Arrange the experimental setup to measure the spring constant. As so in figure 1.3, hand the load holder on the spring, adjust the pointer to the bottom edge of the scale board, add a load to the spring by placing the weight on the load holder, record the load, weight, and the pointer position. Repeat step 3 until the total load weight reaches 118 grams, and record to the result in the table 1.1. Repeat step 1, 2, 3, and 4 for the different spring, and record the result in the table 1.2. Okay. Example of calculation method is a row 1, 20 grams load. Now let's take a look at the first calculation example from table 1 when the mass is 20 grams. The initial position of the spring or 0 is 17 centimeter. After adding a load of 20 grams, the new position of the spring xi becomes 23.1 centimeter. To find the elongation, we use the equation delta x equals xi minus x0. So 23.1 minus 17.0 equals sin is 6.1 centimeter. Next, we need to convert to this value into meter. Because it's physics, we always use SI units. 6.1 centimeter multiplied by 0.01 equals 0.061 meters. The mass of the load is 20 grams, which we convert to kilogram by dividing by 1000. That gives us 0.0 kilogram. Then to calculate the force applied to the spring, we use the formula F equals m times z. Now, where z is acceleration to gravitation equal to 9.x meter per second squared. This means a lot of 20 grams produce a force of 0.196 Newton. Later, all the data point will be plotted a graph of force versus extension if the graph forms a straight line. It proved that the spring following Hooke's law withstood that force in direct proportional to that elongation. You can see the table for my calculation to 20, 40, 60, and other. Is this a table 1.1? And this table 1.2, you can pause this video to see my answer. And the last is the conclusion. Is based on the discussed experimental result, it can be concluded that Hooke's law describes a linear relationship with the applied force and elastic limit. So, thank you very much for your see my video. See you my next video. Bye bye.